Hello everyone, today we've got some more identities for you. And these identities are the sum and difference identities, which basically add up two different angles within a trigonometric function, make it so you could find each angle individually. For example, sine of u plus v equals sine u cosine v plus cosine u sine v. I'm not going to read them all for you, you can read yourself. Before we get into these, I want to quickly remind you of your special right triangles. Here, any right triangle, you can always do Pythagorean theorem to find the hypotenuse. That's just a squared plus b squared equals c squared. We've got our 45, 45, 90 triangle with sides of 1, 1, hypotenuse root 2, and our 30, 60, 90 triangle with sides of 1, root 3, and a hypotenuse of 2. By writing angle measures as the sums or differences of special measures, we can find exact values of non-special angles. A special angle is anything that has a reference angle of 30, 60, or 45 degrees, pi over 6, pi over 3, pi over 4 radians, or if it happens to land on any of our axes. Let's check out how to use these bad boys. Find the exact value of the trig expression sine 15 degrees. Now 15 degrees is not a special angle, but check this out. We can rewrite this as sine 45 minus 30 because 45 minus 30 is 15 and 45 is a special angle and 30 is a special angle. Now let's go ahead and apply our sum and difference formula. Because we have sine 45 minus 30, we want to look for sine of u minus v. Here we have sine u minus v, so we're going to use this guy right here. If we do that, we can see that our u can be represent 45, v can represent 30. Plugging that into that identity, we'll get sine 45 cosine 30 minus cosine 45 sine 30. We can set up triangles for each one of these angles. And that's what I did right down here. I set up my 45 degree triangle and my 30 degree triangle. Now we can start finding values and plugging in. If we want sine 45, that's going to be 1 over root 2. Times cosine 30, that's going to be root 3 over 2. Minus cosine 45, that's going to be minus 1 over root 2. Times sine of 30, which is going to be 1/2. I'm going to take these values here, teleport them down to the bottom so we can solve. If we simplify all this out, we're going to get square root of 3 over 2 root 2 minus 1 over 2 root 2. We have common denominators, so we can put those together. That's going to give us root 3 minus 1 all over 2 root 2. Let's rationalize it, times root 2, and we're going to get as a final answer square root of 6 minus square root of 2 all divided by 4. Let's try doing tangent 7 pi over 12. Again, 7 pi over 12 not special. Let's rewrite this. That'll be tangent pi over 3 plus pi over 4. Pi over 3 plus pi over 4 equals 7 pi over 12. And pi over 3 and pi over 4 are both special angles. Perfect. This is going to be tangent u plus v. So we're going to use this tangent u plus v identity. Doing that, we'll get this big guy right here. Looks like we need to draw triangles for pi over 3 and pi over 4. And here we have both our triangles. It looks like it's a 1, 2, root 3 triangle and a 1, 1, root 2 triangle. Now I'm just going to take these one by one and replace them with their values based on our special triangles. Let's do that all down here. That's going to be root 3 plus 1 over 1 minus root 3 times 1. Let's simplify that further. Root 3 plus 1 over 1 minus root 3. To clear this out, to rationalize, we have to use the conjugate. That's going to be 1 plus root 3 on the top and 1 plus root 3 on the bottom, both of them. That'll give us 4 plus 2 root 3 all over negative 2. Looks like we've got a common factor here. Let's pull that out. That'll be 2 plus root 3 all over negative 2. These are going to cancel, and we're just going to be left, if I move that negative to the top here and distribute, negative 2 minus the square root of 3. Now a tricky part to doing these is finding what two angles add or subtract to give you that angle that we want. For the last example, we did 7 pi over 12. How do we take all our special angles in radians and find out what's going to add or subtract to that? Well, A quick tip I might give you is, let's think of these all with a common denominator. Here we have 3, 6, 4, 2, and of course pi would be over 1. What if we put all of these over 12? Alright, I rewrote each of these with a common denominator of 12. Now, let's see if it's a little easier to find what adds to 7 pi over 12. Well, I've got 4 pi over 12 plus 3 pi over 12. That'll give me 7 pi over 12. Perfect. So if you think about them in this way, we know that that corresponds with the pi over 3 and the pi over 4, and these are the two angles that I want to add. You don't have to rewrite using the common denominator of 12, but if you're having trouble finding out what two angles add or subtract together, this is going to be a one way that many find easier to accomplish that goal. Alright, so far we've been using these identities to go from left to right. We can also go in the other direction. For example, here we have tan 32 plus tan 13 over 1 minus tan 32 tan 13. Now this here, if I'm looking up at my sum and difference formulas, I see that this corresponds with tangent of u plus v. And except for the u plus v, we have the right side of it here. And I notice that my u would be 32 and my v would be 13. Now, if I go backwards, tan u plus tan v over 1 minus tan u tan v, I get that equal to tan u plus v. So I can take this and I can change it to tan u plus v or tangent 32 plus 13. If I simplify that out, 32 plus 13, well, that's going to give me tangent of 45, and I can make a 45, 45, 45, 90 triangle, 1, 1, root 2, and the tangent is going to be opposite over adjacent, or 1. So this whole thing here, simplified, gives you an answer of 1. Keep that in mind when doing some of your homework. You're going to have to go from the right side backwards to the more simpler form.